Okay, so today we're going to talk about dependent, excuse me, and independent variables. All right, so what I want to really focus on is um, X and Y are usually our dependent and independent variables, right? So X is going to be our independent, and Y, or like our answer, sometimes, most of the time, is going to be our dependent variable. And what I want you to think about is that Y is dependent on X. Without X, we don't get a Y. Okay? So Jennifer started out with $50 in her checking account. The amount of money she has in her account after M weeks is represented by the function T equals 50 plus 10M. All right, so let's talk about this formula that we have, this slope-intercept formula. We have Y equals mx plus b. All right, well, our M is our, we're going to get into that, I believe, in the next section or soon, maybe tomorrow even. But anyway, so our M is going to be our slope and our B is our y-intercept, but these are going to be represented by numbers. So I can almost rewrite this as y equals number x plus a number. All right, and then just to color code it even more, we have y equals a number x plus a number. All right, so if we were to line this up, we would have y. This is going to equal, well, 50 is a number, so that's going to be this number. Then we're going to add in another number, which will be this number, and that number is attached to our x. So in this case, m is our x and t is our y. So you guys have to be able to make that, you guys have to be able to recognize that, right? Make that differentiation that it's not always going to be y and x. So what is our dependent variable? Well, our dependent variable is always our y. So if I box it in here, our dependent variable is going to be t. Right? And then it asks us for what is our independent variable. Well, we know independent is x. If I box them in just to kind of put them together, we'll know that that's going to be m. All right, we know that m is going to stand for the amount of money. And we know that t is going to stand for, I believe, total. Starting with 50. The amount of money she has in her account after m. Oh, sorry. So m is actually weeks. And t would actually be total. Right? That's what she's going to have in her bank account after m weeks. All right, so we're just looking for our x's and our y's here, our independent and dependent variables. All right, so a daycare charges $75 for an enrollment fee plus $100 a week. The equation C equals 100W plus 75 represents the cost of using daycare center, where W represents the amount of weeks. Well, we know that we're going to have Y equals number times our X plus another number. And what we're really focused on here is this Y and this X. Well, because we know that our dependent variable is going to be our Y, so our dependent variable is actually C, which is going to be our cost. Our independent variable, the one that gets to work by itself, is going to be X, which in this case is W, which stands for weeks. And this is where I want to talk about why it's independent and dependent, right? Independent gets to do its own thing. So if we have X equals, say, 1, right? Or W in this case equals 1, we know that we can go ahead and plug in a 1 everywhere that we see a W. All right, so when I put a 1 in here, I just simplify, and I will have C equals 100 plus 75, because 100 times 1 is just 100. And when we add 175 together, we just get 175. So you can see that C right here, our Y or dependent variable, is dependent on X in order for us to get an answer. All right, Lisa hired a cleaning service to clean her house to find C, the total cost of her house. She used the following formula. C equals 7.5x plus 25. What is the dependent variable? Notice we're looking for the dependent. Remember, dependent is going to be our Y value. So when I write out our formula that we know, that we've been using, I can just box in where my Y is. Where is my Y? It is right here with my C, which is total cost. And my answer would just be A. Good test taking strategies here. Your dependent and independent variable will never just be a number. Okay, look at this word variable. We're talking about variables, dependent variables, independent variables. So it will never be a number. So right away, you had a 50-50 shot. All right, a local electrician charges for each hour of work. The electrician charges $30 service fee and then $25 for each hour worked. The function is Y equals, this one already gives it to us as Y. Y equals 25x plus 30. The independent variable of this relationship is the what? So we're looking for independent variable. So here we're actually going to have to read the question. We know we're looking for X, but what does this stand for? What does X mean? What does X stand for? Well, when we come back up to the question, the electrician charges $30 for a service fee. So this is $30 service fee is a one-time flat fee. So this is that plus 30 at the back. All right, that's a one-time thing. That's a constant. And then $25 for each hour worked. So this is going to be our independent variable. You kind of get a little hint here with this word each. So $25 for each hour worked. So our independent variable, the one that stands by itself, the one that really makes us think how much the cost is going to be hours worked. And I would just like to highlight here, hour worked, hours worked. Do not get tripped up and make a silly mistake and think hourly fee, right? Nowhere in this problem does it say hourly fee, all right? It does say service fee, and we are talking about a total charged, but we just want to know the independent variable. Total charged would be our Y, that would be our dependent variable. Right, notice a service fee was a number too, right here. And we're never going to use a number as our independent or dependent variable. All right, Joseph has a dog walker on the weekends. He charges a flat fee of $4 to his customers. And then $2.50 for each hour. The formula he uses is Y equals, right off here, Y equals 250 D plus 4. All right, well, notice that our formula is going to be Y equals a number times X plus 4. And we want to line these up. We know that Y is our dependent, and that actually stays the same. And we know that our X is our independent, which is going to actually be D for this problem. So it wants to know what statement is true. All right, so let's read these without rereading the problem. The independent variable is $2.50. Wrong. Can't have a number as a variable. The dependent variable is D. All right, we'll look at that in a second. The Y represents the dependent variable. We'll look at that. The independent variable is 4. Wrong. Can't have a variable be a number. It's going to be a variable, a letter. All right. So let's go through. We have the dependent variable. Dependent is going to be our Y value, right? Dependent is going to be Y. So this is incorrect. But down below, it says the y represents our dependent variable. So we kind of answered it as we were going along. Owen went to Best Buy to purchase a new laptop. He put a down payment, that's a one-time fee, for $200 and will pay $75 each month until it's paid off. He uses the formula P equals 200 plus 75C. All right, well, we know that our normal formula would be Y equals, well, up here we have a number plus a number and our X. So don't let the fact that that our 200 and our 75C have switched places. It's the same idea, but because it's addition, you can move things around like that. All right, so let's see which one of these is going to be, oh, we're identifying which one is false this time. That's a big deal when you guys are taking a test. We're looking for which one is false. All right, so the P represents the dependent. Well, we have P here. P is with our Y. That is true. So we know it's not going to be a good answer. C represents the independent. We have our C with our X, so that is also true. So that's no good. The independent variable is 75. Variable 75, always going to be false. Never going to have a variable be a number. And the C represents the number of months. Well, for that, you're going to have to go back and read the question again. So he says he's going to pay $75 each month. Well, look, we have this each here, so we know that we'll be multiplying. We're multiplying 75 and each month. So we have 75C, and C equals month. So we know that this is also true, and D is not going to be a good answer. So C is correct. All right, Jessica has a job and is paid by the hour. The amount of money she earns is based on the amount of hours she works. What is the dependent variable? So we have to think here, right? We have to think. So we want to look for, let's see, we're going to have our Y, which we know is dependent. And we have our X, which we know is independent. So one of these two ideas in this question is going to make the other idea change, okay? So Jessica has a job and is paid by the hour. So she's paid by the hour. The amount of money she earns is based on the amount of hours she works. So when I look at this, I see the amount of money she earns is based on the amount of hours she works. So if she works 10 hours, she'll get paid 10 hours times whatever her hourly pay is. And the total amount of money she earns depends on that. So the dependent variable will be the money she earns. All right, the amount of money earned. You can throw her hair color out the window right away and her job. And if you were curious, the amount of hours worked is her independent, right? Because she can decide how many hours she works. That's going to change. That can change, right? She can work 2 hours, 10 hours, 15 hours, right? That's her independent variable. She decides that. The dependent variable, or our answer, changes and is dependent on our independent variable. All right, last but not least, Joey's making apple pies. The amount of pies he can make is based on the amount of apples he has. What is the independent variable? I'm going to go ahead and do both for you because it's good practice. And let's talk about what we're looking at. So Joey's making apple pies. Good for Joey. The amount of apple pies he can make is based on the amount of apples he has. I like this phrase, is based on. That gives you a clue. And the amount of pies he can make, I'll include the amount of pies he can make is based on the amount of apples he has. So we're talking about independent variable. So independent variable, because that's what we're looking for, is the one that does its own thing. So if Joey has 10 apples, he can make 10 pies, 20 pies, right? If Joey has 10 apples, he can make 20 pies. If Joey has 1 apple, he can't make any pies. If he has 5 apples, he can make 10 pies, right? So the independent variable is going to be the amount of apples. All right, the color of the apples and the shape of the pot obviously didn't matter. This is amount of apples. And if you were curious, your dependent will be the amount of pies. So I feel like these last 2 questions are really the trickier ones, because you have to think. The amount of pies he can make is dependent on the amount of apples. All right, if you guys have any questions, feel free to reach out. Other than that, have a great rest of your day.